Okay, ladies and gentlemen, welcome back to Math 20-3, Chapter 3, Section 4, Volume and Capacity of Prisms and Cylinders, Part 2. Now, we just talked about calculating volume, area base times height, and I just threw the nice example of you converting unit from one unit to another. In this instance, cubic centimeters to liters, because quite often we measure volume in liters. Not always, but we do. Now, this leads to the one particular thing I have to talk about. Notice the difference between volume and capacity. Now, definition you have to know, because you're going to see this in homework and on the test. Volume is the amount of space a three-dimensional object takes up. Capacity is the amount of material that can be contained within an object. Now, in other words, a mug has volume and capacity, but a brick only has volume. And volume is always measured in cubic units, whereas capacity is usually measured in liters or gallons. Now, this is a picky little thing, but if you think about it, most of you guys drive, or at least you've been in cars, and you know you got to put in gas. What happens if you don't put in gas? You run out. And you got to walk to the friggin' gas station. You got to get one of those containers to put gas in, you got to fill that in, and you got to walk back, and everybody's laughing at you silently. They're not. Poop happens. But I've never had to do that, but I do have a 10-liter gas container for my lawnmower that I have to fill up 3 or 4 times a year. So what's the volume of my 10-liter container? 10 liters. What's the capacity? How much gas can I put in the gas container? 10 liters. Now, a brick has only volume. That is, it has no capacity. It occupies space, but I can't put anything in it. Note the difference. Capacity I can put in it. I have a 1/4 cubic meter plywood volume. That's a horrible example. Who the hell buys plywood by the cubic meter? Flooring. No, that's a dumb excuse. That's dumb. Cement. Yes, I buy cement by volume. I'm going to put in fence posts. I need some cement to put around it. I buy cement by volume. My car has a 40-liter tank. That is, it can hold 40 liters at a maximum. Does it have 40 liters of gas in it right now? Probably not. But it can hold, or it has capacity. Okay, note those. If you want to take a minute, actually I suggest you pause the recording, make a note of this on your blue formula sheet in your own words, because yeah, that's a picky question I'm going to get picky about. Now, moving on. Jill is trying to store her Christmas decorations. She's got 2 boxes. How much more can the second box hold? Now notice one's 2 by 2 by 2, the other's 4 by 4 by 4. So, what I'm trying to say here is, what's the volume of these 2 boxes? Now, I apologize, on your notes, one of the volume got changed to surface area, just, I don't know, humor me. Anyway, so, what is the formula for volume of a prism? Well, it's always area base times height. So, in this 2 by 2 foot box, I'll do this one with you, then I'm going to pause the recording, and you're going to tell me to calculate the volume of a 4 by 4 by 4 foot box. I need you to realize, oh, the base in here is 2 feet by 2 feet, and the height is 2 more feet. So it's 2 by 2 by 2 feet. So the volume is 8 feet. Now, I want you guys to pause the recording, and I want you to calculate the volume for the 4 by 4 by 4 foot box. Okay? So pause the recording and calculate the volume. Okay, guys. When I did it, I got 4 feet by 4 feet by 4 feet, which is 64 cubic feet. All right? So far, so good? All right. Now, that's the important part. The one little thing I forgot to mention. How much more can the second box hold is the question. So, how much more can the second box hold? Well, box 1 is 8 feet, cubic feet. Box 2 is 64 cubic feet. All right? Now be careful. 64 feet cubed minus 8 feet cubed. This box can hold 56 feet more. All right? So normally I'm looking for the difference. But be careful. If you go on video online, they'd ask you to compare these. They might go 64 feet. I wouldn't ask this. What is 64 divided by 8? Well, it's 8 times more. The big box will hold 8 times the little box. Or you can put 8 little boxes in the big box. I want you, whenever I say which holds more, subtract. Okay? Don't do this divide by. Nothing wrong with it, but I want you to do the subtraction part. Okay? Now, last set of questions, and I'll be quiet and leave you alone. Is this the last set of questions? Yes, it is. Right. A bakery store stores flour in a cylindrical bin 70 centimeters high and with a diameter of 50 centimeters. What volume of flour does the bin hold? Okay, that's easy enough. Draw a cylinder. And it doesn't have to be perfect. Please don't spend a lot of time doing it. Diameter of 50 centimeters. The height is 70. Okay, so right off the bat, what's my radius? The diameter is 50, the radius is 25 centimeters. And I should include my units. Area, volume, volume is area base times height. This is a cylinder. It's a circle, so that's formula for area of the circle is pi r squared. Height, so this is pi times 25 centimeters squared times 70 centimeters, and I cannot do that in my head. So I'm going to use a calculator. Pi times squared times 75. 137444. 137445. Now, it's 137,445 cubic centimeters. As I mentioned earlier, with the volume of the lemonade, often we talk about volume in liters. I'm not going to change this to liters because there's a couple more questions in there. But be prepared for that. So, the bakery orders flour in 20 kilogram sacks. Each sack is approximately 46 centimeters wide, 80 centimeters long, 15 centimeters thick. How many sacks of flour fit in the bin? Ooh, sneaky. So, one at a time. Here's the sack. Now, you realize sacks have rounded corners, but here in the drawing, we're talking about how it's roughly a pyramid, or rectangular pyramid. So, 15 centimeters, 46 centimeters, and 80 centimeters. Right? So volume, area of base, times height, or length times width times height. 80 centimeters times 46 centimeters times 15 centimeters. Now I cannot do that in my head, but 80 times 46 times 15 is 55200. That equals 1 sack. Sack. I'm going to spell this just like. So the question is, how many sacks fit in this bin? Make certain you got this, because it's 137,445 cubic centimeter bin. just like we did for liters, 1 sack is 55,200 centimeters cubed. So we divide. 137,445. And if you round it up to 137,444, it's a spacing that's divided by 5, sorry, times 1 divided by 55200, 2.48, 2.5. So this bin holds about 2.5 sacks of flour. And I just answered, sorry. Now I'm going to pause there. I want you to review this and look at the calculations. If you have any questions, shoot me an email. Otherwise, on to the next video.